Hello to everyone. So now I am proceeding to the second lecture where I will explain about miners. So miners play a very important role in blockchain. So basically, who are miners? So in very simple sense, miners are those who actually constitute a new block which is added to the blockchain. So miners are nodes or computational nodes which collect the transactions. So in blockchain, various transactions are floating. So these miners, they collect the transactions. Now what they do with the transaction is, as I explained in my previous lecture, the miners, they find the hash value of these transactions, and they arrange the transactions in the tree structure, uh, and they find the Merkle root. If I go back to the previous slide, here in my previous lecture I explained the miners, they calculate the Merkle root, which is a hash value calculated through the tree structure of the transactions. And then what miners do is they find the block hash value. So block hash value is a unique number which identifies a block, and how this block hash value is calculated by miner. These miners, they append the Merkle root value, which is represented by T, as you can see in the third point. There is a formula where HK is the block hash value, and it is calculated by finding the hash of the previous block hash value, which is HK minus 1, appended with the Merkle root value. And there is a nonce. As I explained in my previous lecture, nonce is nothing but it is a random number. So what miners do, they keep on changing this random number and they keep on finding a block hash value. So till what number of times this nonce value is changed. So for this, it depends on the challenge imposed by blockchain platform. So the blockchain platforms impose challenge to the miner to find such block hash values such that the leading number of zeros are fixed. Like it may happen that the blockchain platform may pose challenge to the miners to find the hash value of the block such that the leading there are 4 or 5 leading zeros, let us say. So normally miners do use SHA-256 function to calculate the hash value. So that function results in 256-bit hash value, and they keep on changing the nonce value such that the leading bits out of those 256 bits are 0, and the number of zeros in the leading bits depend on the challenge imposed by the blockchain platform. So that's why we say that it's written in the fourth point that nonce is the random number. So it depends on the difficulty level set by the blockchain platform. Let us say if the number of zeros that should be there in the block hash value is equal to 10 out of 256 bits. So it will take much more time for the miner to find the valid block hash value as per the challenge imposed by the blockchain platform. So that's why the miners have to use a computational power to calculate the valid block hash value. So once miners are successful in calculating the valid block hash value, they are rewarded by the blockchain platform, and we say that particular block is a valid block. Now, types of blockchain networks in the architecture. So basically there are 3 types of blockchain networks. One we say is public blockchain. So as name sounds, any user who has access to the internet, he can join this blockchain platform. For example, Bitcoin. So anyone can become the part of Bitcoin blockchain network. He just has to install a digital wallet in his computing node. And for example, MetaMask is one of the digital wallet he has to install, and he has to have some valid cryptocurrency in his wallet, and through which he can use this public blockchain network like Bitcoin for doing the transaction. Another type of blockchain network we have is private blockchain. As name sounds, this blockchain network is confined within an organization. For example, if I try to give you a simple example for this, let us say there is a university, and in that university there is an examination system. So that university implements examination system on blockchain. So anyone within the university is only permitted to access that blockchain. For example, only the faculties are permitted to access the blockchain, where they can store the marks of the students in the blockchain. So they can store the marks of the student in blockchain as a transaction, and once a transaction is made in the blockchain, it is permanently stored. So private blockchain is one in which only the member of the organizations are permitted to access the blockchain network. And the third type of blockchain network, we call it as consortium blockchain. So here, in simple sense, I would say that number of organizations they make a group to access the blockchain. For example, let us say in India we have chains of Fortis hospitals. So Fortis is one of the leading chain of the hospitals. So suppose they decide to form a consortium blockchain where they will be able to store the medical reports or the medical history of the patients in the blockchain network. But only the chain of hospitals or Fortis hospitals, they will be allowed to access the blockchain, right? So any member who is any person who is a member of Fortis hospital, which is located in Calcutta, he will be able to access the blockchain network. Or any person who is member of Fortis hospital in Jaipur, he will be able to access the blockchain network. So only members of chain of this Fortis hospital will be able to access the blockchain network. So it is the consortiums or the number of organizations, they make the consortium or group to access the blockchain. Now, consensus algorithm, it's a very important what to say, the prospect of blockchain network. Now, what consensus algorithm means? As name sounds, consensus means to come to agreement on a particular point. So what happens in blockchain network? Many participant nodes in the blockchain network, which we call them as miners. As I explained, who are miners? Who add a new block to the blockchain. So all these computing nodes, which are known as miners, they hold identical copies of the blockchain with them. So there has to be a consensus algorithm such that the consistency of this of the blockchain is maintained. For example, if a particular node is holding a copy of blockchain, then the same copy should be held by another miner, right? So all miners have to update their blockchain with a new block such that the identical copy is maintained by all the miners. So for that, there is one consensus algorithm which is known as proof of work. So as name sounds, every miner which is the part of the blockchain network, they collect the transactions and they try to calculate the valid block hash value. So they collect the transactions, they store the transactions in the block, and they try to calculate the valid block hash value. And I already explained that how that valid block hash value is calculated. It is calculated by appending the previous block hash value and the Merkle root value, and by randomly changing the nonce value, the valid block hash value is calculated. So once a miner is successful in calculating the valid block hash value, the miner propagates that block to all other computing nodes in the network. So if the block is a valid block, then all the miners who receive this valid block and the new block, they have to add that to their blockchain. So that is how this consensus is made to have the consistency of the identical blockchain in the network. So here one example is shown. Here we have three minors. Minor one is there, minor two is there, minor three is there, and this is the existing blockchain. So here we see, for the sake of simplicity, there are three blocks, and if I call it as block one, so block one has transaction T1, T2, T3, T4, which is already mined. This block 2 has transaction T5, T6, T7, T8, and the third block is having transaction T9, T10, T11, T12. So these three blocks are already mined and they are the part of the blockchain network. So if you see this arrow, it means they are chained together, because I told you that the block hash value of each of this block is calculating by using the previous block hash value. So that is how they are chained together. Now minor 1, minor 2 and minor 3, they are in competition to mine a new block. So minor 1 collects transaction T13, T14, T15 and T17, and using these four transactions, minor 1 is trying to mine a new block. Minor 2 catches transaction T13, T14, T15, and using these three transactions, minor 2 is trying to mine a new block. Now very interesting thing is, minor 1 and minor 2, they are holding three same transactions, because all the miners, they are trying to catch the transactions which is there in the blockchain network. So if these miners are part of the blockchain network, they may catch the same transactions. Similarly, minor 3 is trying to mine the block with transaction T13, T14 and T16, and they are in competition with each other. So let us say minor 1 is successful in mining the block, in the sense minor 1 is the first one to get the valid block hash value. So once the minor 1 is successful, then minor 1 propagates this block to all other two miners. So once minor 2 and minor 3 come to know that minor 1 has already mined the block, so minor 2 and minor 3, they stop mining the block, because they contain the identical transactions, that is T13, T14 and T15, which are already mined by minor 1. So minor 2 and minor 3, they can again involve in mining a new block, but with different transactions, not with the same transactions which are already mined. So minor 1 is declared as winner, and he is awarded by the blockchain network with suitable award value, because minor 1 has used computational power to find the valid block hash value. So I will stop my second lecture out here, and I will discuss more consensus algorithm in next lecture. Thank you all.